Welcome to this comprehensive guide on Unity's essential built-in functions, start, update, and fixed update. Understanding these functions is crucial for any beginner Unity developer looking to create interactive game elements. Every C# script in Unity inherits from monobehavior, the foundational class for all Unity scripts. When you create a new script, it automatically includes the start and update methods, serving as fundamental building blocks. The start function is called only once in the script's lifetime, executing just before the first update call. It's ideal for initializing variables, setting initial states, or performing setup tasks that run only once. For instance, you might use start to set up references to other components or initialize a player's health. The update function is called every single frame, making it the most common choice for continuous game logic. Its frequency depends on the game's frame rate. A 60 FPS game calls update 60 times per second. Use update for handling user input, updating UI elements, or implementing simple animations. Here's an example of using update to create a simple timer that logs a message every second. The fixed update function, unlike update, is called at a fixed interval, independent of the frame rate. By default, it runs every 0.02 seconds or 50 times per second, ensuring consistent results. Fixed update is primarily for physics-related calculations and movements, guaranteeing deterministic outcomes. Key differences include fixed updates, fixed timing, and consistent call rate versus updates' frame-dependent nature. Use fixed update for applying forces to a rigid body or performing consistent motion with physics engines. For physics calculations, always use fixed update to ensure consistent interactions regardless of device performance. Read user input and update. Then apply physics controls in fixed update to avoid missed inputs and ensure smooth behavior. If your game logic needs frame rate independence, fixed update is the function to choose. For manually moving non-physics objects, use update. Using fixed update for these can cause stuttering at high frame rates. The execution order of these functions is crucial: awake, on enable, start, fixed update, update, and late update. Awake is called when the script instance loads, on enable when the object becomes active, and start before the first frame update. Fixed update runs at fixed intervals, update once per frame, and late update after all update functions. To make movements frame rate independent in update, always use time.deltaTime. In fixed update, use time.fixedDeltaTime for consistent physics calculations. Debugging with debug. Log helps understand when functions are called and what values are being used. Remember, a lower fixed time step means more frequent physics updates and precise simulations, but also higher CPU load.
To create a new C# script, right-click in the project window, select Create, then C# script, and give it a name.
Attach the script by dragging it from the project window onto a game object in the hierarchy window. Finally, double-click the script to open it in Visual Studio and write your code within Start, Update, or Fixed Update. Mastering these functions is essential for creating dynamic and interactive experiences in Unity. Understanding their differences and proper use is crucial for effective game development.